Yes, sir. We are live now.
Uh, Madam, I
And
want to share the
good
slide.
afternoon.
Madam, I want to share the slide. How to do?
1 second, sir.
Nitya ma'am, shall I start?
Yes, sir. Yes, sir. You can start.
Yes. I welcome one and all present for this pleasant afternoon. And I take immense pleasure and I'm honored to introduce our chief guest today for the first plenary talk. I would like to introduce our chief guest with a few words. Dr. Kannan Arpudaj is currently working as a senior professor in the School of Computer Science and Engineering, VIT Vellore, India. Earlier, he was a professor in the Department of Information Science and Technology, Anna University. He was in software development at BARC Bombay from 1981 August to 1989 March. His areas of interest include DBMS, artificial intelligence, and information security. He published 11 international journals. So I would like to just welcome, and I would like to please invite our guest for the first plenary talk today. Sir, please, sir.
Sir, there is an option called share, sir. You can directly share your system. Yes, sir. Your system is visible.
My screen is visible, madam.
Yes, sir. Yes, sir. Your screen is visible.
Yes, sir, it's visible.
Okay. Good afternoon to all of you. I am Dr. A. Kannan. I am a retired professor from Anna University, working as a senior professor in VIT Vellore. Uh, just I will show my research work. After that, I will have is my Google Scholar citations. So right now I have 417 citations with a H index of 35, and I have published around 400 papers in journals and conference proceedings. Now I am coming back to the presentation. I am going to talk about e-learning challenges and the support of AI and data science for doing e-learning. We are conducting a conference on digital world after the arrival of COVID. Before the arrival of COVID, we were not much bothered about the use of digital. But the classes were conducted online. During the COVID period, all the universities, all the colleges, they went for online classes. And we wanted to provide the contents, e-learning contents, and purchases also we were doing through e-purchase, e-business, e-services, everything. In this way, we were able to continue with our work because of the computers and the communication technology, along with the technologies like AI, ML, and database systems. I am working on the areas of artificial intelligence, machine learning, and database systems, and some work on computers, uh, communication, and network security, etc. So I will be throwing light on e-learning based on these technologies. First, e-learning is successful because of the presence of artificial intelligence and machine learning. In many colleges, they have started a branch called BTech, Artificial Intelligence and Machine Learning. Wherever you go in the industries, the buzzword is artificial intelligence. In the year 1956, there was a conference. It was conducted by a mathematics professor called John McCarthy. He termed the coin artificial intelligence. The aim of artificial intelligence was to make the computers to do things like human beings, what we are doing. Right now, human beings are intelligent. Computers are not having common sense. They are not intelligent, but they are able to carry out the instructions given by human being in the form of programming. But what we want to write further programming is, they must be able to recognize your face. They must be able to recognize your voice. They must be able to communicate with you in a language which you are very familiar. That means natural language processing across different natural languages must be there. In this way, they wanted to develop intelligent computer programs. That is the aim of artificial intelligence. When artificial intelligence was proposed by mathematicians, they used it for theorem proving. For example, in graph theory, two important theorems were not proved: four-color theorem and five-color theorem. In the simplest form, in algorithms, if you study, you are given many different colors. You want to color a triangle, let us say, simple object I am taking, the vertices of your triangle with the different colors in such a way that no two adjacent vertices will have the same color. If you want to color the triangle with different colors in such a way that no two adjacent vertices will have the same color, you have to use three colors. But when you go for a rectangle or square, suppose you are starting with top right corner with color 1, you are coming down with color 2, then coming to the left, color 3, going to the top, color 4, 4 colors you will use. But it is not necessary. Opposite corners you can use the same color. If you do like that, with the two colors you will be able to color the rectangle. So color 1, color 2, once again color 1, color 2 for the vertices if you do. With the two colors you are able to color the 4 vertices of your rectangle. For a triangle, if you want to color with two colors, it is not possible since some two adjacent vertices will be having the same color. We have to color in such a way that any two adjacent vertices should not have the same color. This principle they applied for coloring the world map. In the 4-color theorem, they say that you have to use only 4 colors. You have to color the world map in such a way that no two adjacent countries or no two adjacent states will have the same color. For this, mathematical proof was not there. Computer program was written. The program was able to solve the problem. Later on, they developed an algorithm, and after developing the algorithm, it was converted into mathematical proof. So in this way, AI is used in many areas of mathematics, including theorem proving, perception. In perception, when you see the person, you are able to recognize him. Suppose your childhood friend is there. After so many years, if you are seeing also your schoolmate, you are studying in a college or working in a college, you are able to recognize the face of a person who was seen by you 15 years before or 20 years before, because you have a perception capability. But the computers, they cannot perceive like that. You have to give a recent photograph. You have to train with more than one recent photograph, then only it will be able to do perception. So the perception theory in artificial intelligence, they want to train the images of a person from childhood onwards up to so many years. Every year one photo or one image will be taken. It will be trained, and how the face is changing, how the structure is changing. That training if you give, they will be able to identify the people like the human beings are doing. Robotics is another area of artificial intelligence. It is used everywhere, at least for weightlifting. It is used as a receptionist. It is used for teaching also in classes. It is used for transporting, like that. Medical assistance it is providing, like that. So many robotics are there. That is another area. Natural language processing is the most important area that is used for text mining. You have to provide the correct contents to a e-learner. In e-learning, what is more important is getting the correct content. When you go to the library, digital library, if you are browsing, you will be getting so many materials on a subject. But which material is more relevant to you, more easy to follow, that details will not be available without natural language processing. So natural language processing provides you to do semantic analysis. This semantic analysis will allow you to take the most relevant information from the repository available. Next area of artificial intelligence is common sense reasoning. People wanted to use computers for doing assistance in all our activities. One example is a general problem solver was developed. It has to help the human beings for making them to get up early in the morning, advise them to take or request them to take bath, take the breakfast, and take the books necessary to go to the college, do the work. For everywhere it has to assist. And like encyclopedia or Wikipedia, if you ask any question, it must be able to provide an answer. That is the general problem solver. They were feeding with all the valid knowledge, and they asked the question, what is the phone number of Shakespeare? It was searching through the database and told that no record is found. But when the same query was posted to a 5th standard child, she told which Shakespeare. Is it the Shakespeare who wrote English dramas? If it is so, during the time of Shakespeare, there was no telephone since telephones were not invented. So your query is wrong, like that, she answered. The child has common sense. That is why she did not search through the database in the brain. She was asking which Shakespeare, and when telephone was invented, she is connecting with that, and she is answering very intelligently. That is only common sense reasoning. In artificial intelligence, we have common sense reasoning. When you go to doctor, the doctor will be expert in only one domain. Similarly, in subject also, everybody cannot be a subject expert in all the subjects. In computer science, if you take, some people are expert in network, some people are experts in programming, some people are experts in database systems, some people are experts in software engineering, some people are experts in data structure algorithm, some people are experts in operating systems, some people are experts in theory of computation, compiler, etc. Like that, different experts are there. When you develop an expert system for medical diagnosis, let us say, you cannot provide the expertise of all the people. So for a particular domain, let us say the dental programs or heart problems or diabetes problem, like that, for a particular problem, you can develop an expert system. You go to the domain expert, who is a doctor, interact with him, get the knowledge acquired by him, and convert them into a rule, develop an expert system. Once you develop an expert system, the patient need not go to the doctor directly. He can consult with the expert system, take a printout on the suggestions given by the expert system. If you go with the suggestions from the expert system, the doctor will have less time to diagnosis. He can do diagnosis very fast and more accurately. That is why expert systems are very important. The next area of importance is game playing. So in game playing, there will be two people or two players, two sides, let us say. In artificial intelligence, we have an algorithm called minimax algorithm. In the minimax algorithm, when you play for you will try to maximize the chances of your winning. When the opponent is playing, you will try to minimize the chances of his winning. That is maximizing play and minimizing play. In cricket also, when you are batting, you will try to maximize the score of you in order to maximize the chances of your winning. when the opponent is batting, you will be trying to bowl in such a way that you are trying to minimize the score of the opponent. This algorithm is called the minimax algorithm. So that minimax algorithm is put into use in many real life applications. That is also a gift from artificial intelligence. The most important gift given by artificial intelligence is machine learning. Everybody is learning continuously. As a teacher, you will be learning every day. If you are going to some other work, let us say you are doing a small business, the same work you will be doing throughout your life. You need not learn many things. Few things you can learn, that's all. But for a teacher, he has to do research, he has to study new subjects, he has to teach different subjects with different new textbooks. New technologies will come, he has to adapt. Therefore, he has to learn continuously. Machine is also learning through rules, and the learning is making useful changes in your minds. That is the quotation given by Marvin Minsky. Machine learning refers to a system which has the capability of autonomous knowledge acquisition. Autonomous knowledge acquisition means without the support from a human being, it will be interacting with the people and it will get the knowledge, or it can sense the world and acquire rules and store in the knowledge base. That way it is having the power of autonomous knowledge acquisition, and it will integrate all the knowledge acquired by it and organize it into a knowledge base so that a domain expert can use it for making inference. There will be an inference engine. That inference engine will apply the rules and make decisions. It will help the domain expert to make more efficient decisions. So the machine learning is one application of artificial intelligence. It will apply rules that is gained from experience, and it can be used to make decisions by classifying the objects, for classifying the data, classifying the images, and so on. Some applications of machine learning are image processing, natural language processing, medical diagnosis. In the image processing itself, you can develop applications for face recognition, handwritten character recognition, self-driving car development, traffic video analytics, and so on. Similarly, with the traffic video analytics, you can find the route with less congestion. You can avoid the congested route. You can go to a better route. With natural language processing, you can do social network analysis, which people are visiting which web pages and which products are liked by many people. You can develop recommendation systems for buying products. You can analyze the sentiments of people, whether they are happy with your product or they are not happy with your product, everything. In the medical diagnosis, you can identify a disease, you can predict a disease like prediction of cancer, diabetes, etc. using the past data, current data, and the rules used for our changes. So machine learning paradigms are: you can do rote learning, that is by-guarding and storing, or computing and storing the information, later on retrieving. This rote learning is powerful with the computers, since you cannot remember everything in your brain, but the computers will be able to store and retrieve very fast, and it can remember for many years. That is why rote learning with the table, for example, multiplication table, if you are asking me to say what is 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, like that I can say. Even 16th table, 16 1s are 16, 16 2s are 32, 16 3s are 48, 16 4s are 64, 16 5s are 80, like that I can by God and tell you this is rote learning. This rote learning is better with the machine learning, machine computers. That is the first type of learning we did. Any child, when you teach, you will be teaching them about ABCD or 1 to 3, multiplication table, spellings, everything rote learning we are doing. After that, you have to go for acquiring more knowledge, inferencing, and deducing new knowledge, etc. For this transfer of learning, suppose you are learning cycling, whatever skill you are acquiring in cycling, that skills you can apply while driving the two-wheeler without gear. Now, two-wheeler without gear, if you learn, you can learn two-wheeler driving with the gear. And once you learn two-wheeler with the gear, you will be knowing what is clutch, what is accelerator, what is brake. With this, you can learn car driving. In this way, you are transferring the learning from one uh, learning environment to another learning environment. That is a type of learning called learning transfer of learning. Next, learning by taking advice. You can learn by taking advice from a supervisor in PhD, a guide in project guide. From a teacher, you can learn. Similarly, in working environment, a senior person can guide to give advice. A junior doctor can get advice from a senior teacher, senior doctor. A junior advocate can get advice from a senior advocate. Like that, learning by taking advice, that is also important. Suppose you are developing a medical expert system, you can go to a doctor, you can take his advice, refine your system based on the advice given by him. Learning by analogy, learning by comparison. Suppose you want to compare human beings and computers. Minsky was a person who was doing learning by analogy. He wanted to compare human beings and computers. For this, he did an experiment with human beings with pig. He compared human beings with the pig by comparing the head of human being and the head of pig, eyes of human beings with the eyes of pig, nose of human beings with the snout of pig, mouth of human being with the mouth of pig. Like that, he compared and found that the human beings are exactly like pigs, and the pigs are like exactly like human beings. Like that, he found similarities. But when he was doing the experiment, he brought a pig inside his house. He was making it to put in a sofa, sit in a sofa. He was giving delicious food. He was giving air-conditioned room, but the pig was not happy with that room, with that food. It was drying. It was seeing a drainage water outside the room. It was jumping through the window. It was jumping into the drainage water, dirty water. There it was enjoying very much. It was very happy than sitting in the AC room, than eating delicious food in the AC room. It was happy in the dirty water. That is why he came to the conclusion that men are neat, pigs are dirty. Men are well mannered, pigs are ill mannered. Therefore, pigs are not equivalent to human beings. Like that, he concluded. Next, he wanted to compare human beings and computers. Computers are able to store, human beings are able to store in the brain. Computers are able to retrieve. Similarly, human beings are able to retrieve. Like that, he was going on comparing human beings and computers. He found that both are same. We are doing computations. Computers are doing computations. We are comparing. Computers are comparing. Like that, so many uh, sorting, searching, arranging, indexing, like that, so many similarities were there. But human beings are having common sense knowledge, but computers are not having common sense reasoning. That is what he found and told that human beings are superior right now. We want to make the computers to do things like human beings in future. For that, we have to teach them, and learning will be done either through unsupervised mode or supervised mode. In the unsupervised mode, like clustering algorithms, take the example of K-means clustering algorithm. You will tell how many clusters are necessary. It will form that many clusters by measuring the distances. But in the classification, it will be using some formula for classifier. For example, decision tree means it will find the information gain. Based on that, it will divide the tree into left subtree, right subtree, like that it will be going on up to the time we reach the leaf node and make the decisions. That is a type of supervised learning. Even with the supervised learning, like neural network, the accuracy was less. So the people went for deep learning, in which large amount of data set, large amount of hidden layers, large amount of training, and new type of networks like for automatic feature extraction, automatic feature selection, they are putting max CNN if you take like convolution layer, max pooling layer like that they are taking. Similarly, in activation function they are using max soft layer. So max soft function they are using. You may be using the same sigmoidal function also like that. Different options they are giving. Finally, you will be ending with a fully connected layer and doing the classification. In this way, machine learning is helpful. But the fundamental thing in artificial intelligence is any component of AI, whether it is natural language processing or image processing or robotics or uh, just a classification problem or clustering problem, anything in AI will be dealing with facts and rules. Facts are anything for which we can assign a truth value of true or false. For example, if that is a man is true and it is a fact. That is a woman can be false. Kumar is the father of Raja equal to true. And Kumar is the grandfather of Raja, it may be false. If marks greater than or equal to 0, then class equal to first class. This is a rule. So rules are given in the form of if-then statements. Facts are given in the form of true or false statements. Now, some more rules. If A then B, you can say arrow mark in the last line A implies B. That means if A then B. A equal to true, whenever A is true, then B is true will be written as A implies B. This rule is called modus ponens. If A implies B, comma A, whenever A implies B, whenever A is true, B is also true. Now A is true. Whenever A is true, B is also true. Now A is true. Therefore, we can infer that now B is true. This rule is called modus ponens. I will give examples for inference. That is a man. If you represent the knowledge using the simple predicate or proposition P, you are representing the knowledge. That is a woman using the proposition Q. That is a man or woman will be represented as P or Q. That is not a woman will be represented as not Q. Inference is P is true. That is a man or woman. That is not a woman. Therefore, that is a man. That is only P is true. The sentences I am saying in the last 3 lines. That is a man or woman. That is not a woman. Therefore, we infer that is a man. There is a difference between knowledge-based systems and database systems. In the database systems, more amount of data will be there, and less amounts of rule will be there. But in knowledge-based systems, more rules and less facts will be there. In knowledge-based system, we will have a domain expert. For example, you want to develop a expert system for heart problem, the domain expert is heart specialist. You want to develop an expert system for civil engineering applications, let us say house building, the domain expert is civil engineer. The process of developing knowledge-based system is called knowledge engineering. The person who is developing a knowledge-based system is called knowledge engineer. Knowledge-based will consist of knowledge, that is nothing but the collection of facts and rules. The difference between knowledge-based system and database system is knowledge-based systems are having more rules, less facts, and the database systems are having more facts and less rules. One example of database application is railway timetable book. In that, more data, that is more train timings are given, less rules on reservation rules and cancellation rules will be there. You take the example of a knowledge-based application like chess playing game. In chess playing game, 2 power 35 rules are available. In which way you are applying the rules, that will decide whether you are a winner or loser. That is why it is done by experts. So the updates will be done by experts. But database systems can be like railway reservation, it can be updated by clerks also. Knowledge-based systems are kept in the main memory since the rules are very less. But database systems are having more amount of data, so they are called disk-based. In knowledge-based system, fact and rules can be kept together. But in database systems, rules are called triggers. They are not stored inside the table. Data are stored in the table. Triggers are stored elsewhere. These are the difference between database systems and knowledge-based systems. I distinguish between AI programs, knowledge-based systems, and expert systems. AI programs are computer programs that perform um, heuristic search and exhibit intelligent behavior by the skillful application of heuristics. And the knowledge-based system is a subset of AI in which the domain knowledge and problem-solving knowledge are separated. Expert systems are knowledge-based systems in which we consult with the domain expert and develop the intelligent system. The expert system will have two components. One is called knowledge-based, another is called inference engine. They are connected with each other. The knowledge base consists of facts and rules. The inference engine has two components, namely interpreter and scheduler. The interpreter will execute the rule, and the scheduler will take which rule to apply first, tell which rule to apply first, which rule to select second, and so on. It will perform deductive inference, means it will do inference based on what is available through facts and rules. It can do reasoning based on time, space, comparison, etc. It will use mathematics like first order logic, higher order logics like fuzzy logic, etc. It will use knowledge representation techniques like tables, database tables, rules in the form of if-then statements, semantic networks in the form of trees, graphs, etc. It uses search techniques like just a depth first search, or heuristic search like A-star algorithm, A-O-star algorithm, etc. They are used in information retrieval. The artificial intelligence and database systems are very important in the area of information science and engineering. Any IT company, now they are using AI and database systems. Previously, software engineering and database systems were considered most important. Now, software engineering is also important, security is also important, but two important pillars for decision making are database systems and artificial intelligence. If you know them very much, then you can retrieve the information from the database with relevancy score, relevant information retrieval. When you are searching for research paper for doing the PhD, if you are searching through the library, IEEE library or Elsevier library or Springer library or any other digital library, you will be getting more number of documents than necessary. But which documents are more relevant to you, that you have to find now. Previously, before the arrival of digital, we used to go to IIT library, Instack library, or NIT library, Anna library, and so on. Very few journals will be available in each library. We used to search each and every journal for getting articles of our areas of interest. Literature survey itself used to take 1 year. Similarly, when you write a paper and communicate through a post, even to get an acknowledgement will take 1 month. It will be reviewed for 2-3 years. So the PhD process will be around 10 to 15 years for many people. After the arrival of internet, we are submitting the paper through internet. It is reaching them within a day. It is going to review within 2 days, 3 days. They are finding the reviewer within 1 week. It is going to the review process within 2-3 weeks, 2-3 days. Then review is completed in 2 weeks or 3 weeks. It is coming to us. Then major revision, minor revision, like that, everything will be taking 1 or 2 weeks only. After doing revisions, finally the acceptance may be coming in 2 months, 3 months time. Previously, it was taking 2 years, 3 years time. Now we are getting very fast because of the fact that digital communication is available. Through that, we are getting many materials, but we have to find the correct information only now. Recommendation systems are available to choose the correct product in the e-commerce. Similarly, to choose a journal also recommendation systems are available. Which journal you want to publish, which journal if you send your paper, it will accept your paper very quickly, which are free journals, which are paid journals, which journal will expect mathematics, which journal will expect algorithm, which journal will do fast review, which journal will do slow review. All that things can be recommended. Product also can be recommended. You can see the review for products, review for colleges, review for schools, review for anything you buy in the internet. you can find the recommendations. Even for e-learning contents, you can have the reviews, the most relevant and useful contents you can take for learning. Natural language processing was considered to be dead previously. Now, after the arrival of internet and after the resumption of AI and ML in the recent years, every college is getting admissions on computer science and engineering, IT, AI, ML, AIDS in these branches because of the powerful support provided by natural language processing. It is artificial intelligence, data science, database management system, NLP. They are all providing powerful tools for analyzing text, analyzing nowadays video analytics tools are available, image analytics tools are available, audio analytics tools are available in addition to natural language processing. So all these things are mainly natural language processing is dealing with syntax and semantics. If you take 4 and 4 makes 4, 4 and 4 makes 2 and 2 makes 4, which is syntactically correct and semantically correct. 2 and 2 makes 5, it is syntactically correct but semantically wrong. That syntax analysis and semantic analysis both should be done if you want to make a good decision based on the text mining. So e-learning contents are provided based on syntax analysis, semantic analysis, morphological analysis, pragmatic analysis, next sentence, anapara resolution, like that. So many phases are available in natural language sentence, natural language processing. In text mining also we do classification, clustering, but relevance feedback we are getting, we are finding the associations, and based on the associations we are finding the relevant information. Now people are moving from normal data to big data, and big data exceeds the reach of commonly used hardware and software. Therefore, its size is coming higher and higher, bigger and bigger. We cannot just capture and store in the normal computer. We cannot use normal tool to analysis. Therefore, special tools are necessary. That is why people are expecting the arrival of very fast computers like quantum computers. In AI, for AI applications, they need quantum computers. The big data will be arriving very fast, and it has volume, velocity, variety. It will have structured information, unstructured information, real-time data, terabytes of data. At least it is not like bit, byte, megabyte, gigabyte. It is in terabytes, petabytes, nanobytes, like that. Then it can be generated from sensors, RFID tags, mobile phones, everything, and it automatically generated by a machine. It is in structured format, unstructured format, semi-structured format. It is not user friendly. One example of big data is Facebook data, Twitter data. In the past, people were going for database systems in the supermarket. Now we are having cloud data centers. We are storing very large amount of data in the. In future, if the size of users in Facebook, Twitter, everything is increasing, the amount of data will be added. More amount of data will be added daily. It is not possible to store in cloud data centers. We have to go for better storage and retrieval facilities in future. Even big data handling is difficult. That is why for e-learning, not only for e-learning, any type of learning or discussion in future, we have to go for big data analytics. It has many challenges, including security and cost. Next, if you are having only past data and the current data, you will not be able to do analysis. You have to analyze by expecting the future data. So you have to provide facilities for storing structured data, semi-structured data, unstructured data. You have to build data warehouses. You have to build databases, like that. So many repositories you have to build. Then you have to do the analysis. You have to do more. You have to spend more time on data gathering and arranging that. If you are arranging well, even if you are throwing your books in a library or in a house, thousands of books you are in your house. If you are coming and throwing one upon another, it is very difficult to search. But if you are indexing and arranging one area for AI books, one area for database books, one area for programming books, one area for operating system books, one area for security books, like that, if you are arranging, it is easy to search. Author index, subject index, like that, people are doing indexing. So you have to collect the data, arrange them with indexing, store them efficiently so that it can be analyzed very efficiently. So I am going to do the conclusion of my talk. Decision making is possible with big data analytics using artificial intelligence and machine learning techniques. Fuzzy logics and hierarchical logics can be used for handling incomplete information, and complete information can be handled with any types of logic or the query languages. Intelligent behavior should be captured so that you'll be getting more relevancy. Like indexing and hashing in knowledge representation. In AI, we have knowledge representation techniques like semantic networks, frames, conceptual dependency, scripts, etc. We have logics like propositional logic, predicate logic, temporal logic, uh, epistemic logic, model logic, like that. So many logics are available to handle both complete data and incomplete data. We have search technique like depth first search, breadth first search, hill climbing, A star, beam search, branch and bound, AO star algorithm, minimax algorithm, like that. So many search techniques are available. All these features from artificial intelligence and database systems, if you are applying them on big data analytics, then the e-learning and recommendation systems will be formed by you. You can do any type of e-learning. You can do digital discussions. You can do digital meetings. You can do any type of digital. You can provide any type of digital services. The world can be becoming digital with the strong use of artificial intelligence, big data, and data analytics. That is what I want to conclude. Thank you.
Thank you
You
so
have
much.
any doubts? You can discuss your doubts.
Yes, sir. Thank you so much for your detailed version of your things, sir. On behalf
Okay,
of
madam.
our students, I'm requesting Dr. Muruganathan to clarify the doubts. Sir, Muruganathan, sir.
Yes, madam.
Ma'am, there.
Yes, sir. Yes, you can ask, sir.
Thank you, sir. Ma'am, am I audible?
Illa, sir, you are not audible. You are not audible. One second, sir. Our speaker is exited. 1 second. Our backstage இருக்காரா பாரு. Sir, excuse me, sir. Yes, you
Yes,
can hear
madam.
us. Yes, sir. You can hear us, no, sir.
Yes, madam.
Yeah. Muruganathan, sir, you can start your question.
Sir, thanks for the wonderful talk and really enlightened. And few questions are there for your
Sir, excuse me, your voice is not clear. Muruganathan, sir.
Ma'am, is it audible now? Hello.
Now you unmute.
Is it audible clearly, ma'am?
Yes, yes,
Yes,
yes.
sir.
Yes. So question number 1. So
Yes,
what skills are really needed to be involved in artificial intelligence research?
Yes, sir. You must know how to create rules, how to apply the tools. In machine learning, every algorithm, when you do the training, it will form the rules. When you do the testing, it will apply the rules. Therefore, if you are learning the fundamentals of artificial intelligence on how rules are, how knowledge is represented, how rules are stored, after that you learn machine learning algorithms, that will be sufficient. For doing research, any type of research, suppose you are working on network, intelligent networks. If you are working on databases, intelligent databases. If you are working on image processing, you can apply machine learning algorithms. If you are working on medicine, you can do medical diagnosis with machine learning algorithms. So if you learn machine learning algorithms, that will be the boost for any type of research.
Thank you, sir. Really, thank you. Question number 2. What are all the various domains of artificial intelligence?
Yes, sir. In artificial intelligence, my domain is always knowledge engineering, sir. In this knowledge engineering, I am working on not only propositional and predicate logic, mainly fuzzy logic, then rough set theory. I am working on temporal logic. I'm working on agents and epistemic knowledge, intelligent agents and epistemic logic, and so on. Some people are working on machine learning, some people on robotics, some people on image processing, some people are working on natural language processing, some people are working on theorem proving, some people are working on search algorithms, some people are working on knowledge representation. Like that, different people are working on different domains. My domain of interest is logic, mainly fuzzy logic, temporal logic, etc.
Yes, sir. And the final questions for this session. Then, what type of programming language can be used for NLP?
Yes, sir. Previously, when I was doing research, we were using Prolog and Lisp. Then we went to Common Lisp. That was an object-oriented programming language. Now, Python language is the latest one. With Python, all programs you can write for AI and ML applications. So I recommend Python. But with Java also you can do. With any other language also you can do. But the libraries of Python, even list operations. Yesterday I was conducting lab examination. I was asking them to create linked lists and to do operations. The people who were using C, C++, they were using pointers to do the list operations. They were found very difficult. But the people who were using Python, within a line of command, they were able to create a list, insert element, update element, everything they were able to do with list operations very easily. Therefore, for AI programming, Python is the latest one and the most useful programming language.
Okay, sir. Thank you. Thank you so much for your patience answering for all the questions. Ma'am,
Yes, sir.
thank you, ma'am. Thank you so much.
Thank you, sir. Thank you very much for your insights and other thoughts. Now I request Dr. Uma Devi to deliver the vote of thanks.
Good evening, all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I'd like to thank all the honorable delegates who blessed us with their presence. I'm also very much thankful to all committee members and the invited speakers. Words are not enough to thank their constant guidance and support to shape the conference. I, on behalf of the organizing committee, convey deep regards and hearty thanks to our Honorable Founder Chancellor, Dr. A.C. Shanmugam, President Engineer ACS Arun Kumar, They supported in all possible manner to organize this conference. I would also like to thank our Vice Chancellor, Dr. Geeta Lashmi, for various help we received towards this conference. I am very much thankful to all our faculty colleagues of FOCA and non-teaching staff members who always stand by us and motivate us. I feel proud and thank you for making this event a successful one. I thank Dr. Kannan Arpudaraj for his valuable information, and the way he motivated the students is an extraordinary way. So if time is money, then today you have spent millions for us, sir. Thank you very much, sir. So an event of this dimension cannot happen overnight. The wheels start rolling months in advance. We have been fortunate enough to be backed by a team of very motivated and dedicated students committee and volunteers. Thanks to all of you for making this event successful. Enjoy the conference. Thanks. Thank you, ma'am. Thank you, sir.
Yes, ma'am.
Thank you very much, ma'am. So with this, we are closing today's session. We'll meet tomorrow with other exciting plenary talks and panel discussions. Thank you, one and all. Thank you.